How does this 3D object went from being a bunch of triangles to becoming pixels on your screen? How does computer graphic works? We often hear about game engines like Unreal, Unity, Godot, but what about the game engines of the game engines? I'm a computer engineering student, so I usually deal with stuff like capacitors and diodes. But this semester, I decided to take a break from circuits and learn about graphic programming. Computer graphics is all about creating images, animation using computers. It's what makes video games, movies, and pretty much everything you see on a screen possible. Now let me explain the graphics pipeline. This is the process that transforms a 3D object into 3D pixels that you see in your screen. The pipeline includes several stages: vertex processing, shape assembly, rasterization, fragment processing, and per fragment operations. First, we have the vertex processor. Here, each vertex position and attributes like color, texture coordinates are processed. Think of vertices as the corners of your 3D object. For example, if we have 4 vertices, we label them as 1, 2, 3, and 4. Next is clipping and primitive assembly. In this stage, the vertices are connected to form geometric shapes, such as triangles or lines. Then comes rasterization. This is where our assembled shapes are converted into fragments, which are essentially potential pixels. The shape is broken down into a grid of fragments that will later become pixels on your screen. In fragment processing, each fragment's color and other attributes are determined. This step involves applying textures, lighting, and shading to give our fragments the correct appearance. Now our fragments have colors and details. Finally, we have per fragment operation. Here, additional effects like depth testing and blending are applied to ensure that the fragments are currently combined to form the final image. The fragments are then returned to the frame buffer as actual pixels. And that is how the graphics pipeline works. It transforms the vertices into fragments and eventually into pixels that form the images on your screen. By understanding these steps, we can create complex and detailed graphics using OpenGL. In the pipeline, we are interested in 2 steps: the vertex and the fragment. It's in the steps where we can do some modification in order to alter the appearance of an object. This can be done with something called shaders. Shaders are programs that runs on the GPU. Let's say we have a 2D triangle and we want to alter its look. Let's say we want to scale it. We can use linear algebra to do so using matrix multiplication. We can do all sorts of things to that triangle, like rotation, scaling, and translating. As you can see, these operations are done on the vertex side, meaning to scale it, we need to modify the value of the vertices. Now, let's say we wanted to change its color. Let's say we want to make it shinier or like different color. These would have to be done in the fragment section. Okay, so now let's get programming. Using VS Code, we will need these 3 libraries. So the first step is to define our triangle. A triangle consists of 3 points / vertices. In our case, we'll use these. So now if we want to be able to add and modify the attributes of this potential triangle, we'll need vertex shader and a fragment shader. This is done using GSL. GSL stands for OpenGL Shading Language. In the vertex processor stage, each vertex position and attributes like color and texture coordinates are processed. So the string of the GLSL code can be summarized as follows. Initial vertex position. A pose is the original position of the vertex in object space. Transformation matrix. Transform is a combination of various transformations such as translation, rotation, and scaling. The homogeneous coordinates. Vec4 with a pose and 1 converts the 3D position to a 4D vector matrix multiplication. Resulting position. GL-position is the final position of the vertex and clip space. Now let's move on to the fragment shaders. In fragment processing, each fragment's color and other attributes are determined. And this slide represents the RGB color system, and the last one is the alpha. So 0 is transparent and 1 is opaque. So this is a bit boring, so I decided to make the use of what we learned in high school using sine wave to control the value of each of the colors parameters, like to have a dynamic color effect. And that's how the graphic pipeline works. It transforms vertices into fragments and eventually into pixels that form images on your screen. By understanding these steps, we can create complex and detailed graphics using OpenGL.